Hello, my name is Joanna Henry, and today we're going to be talking about truth tables. So, what is a truth table? Well, a truth table is a table that gives the truth values of a compound sentence. And if you remember from English class, a compound sentence is actually two complete sentences joined by a conjunction. You can see the word and, not, or, but. And what we will do is determine that truth value once those two statements are put together. Okay, so why do we need to know this? Well, truth tables actually show whether a statement is valid or not. And also, if you're an IT person, you probably have seen these at some point or another. They can be used to reduce basic Boolean operations to simple correlations of inputs to outputs. And in math, we do a lot of problem solving. Well, truth tables are a really good way to enhance your problem solving skills. It makes you really look at things deeply and problem solve to find answers. All right, let's talk about the symbols that are used in truth tables. Here's a good list. As you can see, the first one is our negation symbol. It's a little tilde. You'll often see the word not associated with negation. Second one is conjunctions. That's your upside down V. And typically you'll see the word and, but remember it could be and or but or yet. Third one is a disjunction, which is your V shape. Those are our or statements. Next one, conditional. Those are your single arrows, and those are your if-then statements. And last, we have biconditional, which is, as you can see, a double arrow. And those are our if and only if statements. So let's start out by looking at an example of each of these. So what does it mean to negate? All right, let's start with a statement. We're going to call that statement P. We often assign a variable to our statements. We're going to use the letters P and Q throughout this. So if we have any statement P and we assign a truth value, let's say the sky is blue. Well, that's true. So we'll assign a truth value of true for our statement P. To negate it simply means do the opposite. So a true becomes false. The sky is not blue. Okay? And if our original statement starts out false, to negate it, of course, we would turn it to true. It's as simple as that, turning it to the opposite truth value. Okay, next we have our conjunctions, which are our and statements. So this time I'm going to have two statements. I'm going to actually give you the statement. 4 plus 5 equals 9 is our P statement, and 3 times 5 equals 20 is our Q statement. So think about what truth values we're going to assign to those two statements. Now, the problem we're going to be given is a compound sentence like P. And then what's that upside down V represent? If you recall, that's our and. Okay, and. So our statement is P and Q. What is the truth value of that compound sentence? All right, first thing we're going to do. Here's a typical example of a truth table. I've already filled in the headings for us. We need to know what P is, what truth value. We need to know the truth value for Q. And then once we know those two individually, we can put them together and determine the truth value for P and Q. And there are rules. We'll talk about the rules as we go along here. All right, let's start by assigning P and Q a truth value. So for P, 4 plus 5 equals 9. Well, that is true. 3 times 5 equals 20. No, that's not true. So we're going to assign a false for Q. Okay, now we need to know the rule. So what if I put these two together with an and symbol in between? What would my truth value be then? Here's the rule for conjunctions, and I strongly suggest you memorize these rules. This is really going to help you. Conjunctions are true only when both statements are true. Okay, so I have to have two individual statements that are both true in order to give me a truth value of true. Okay, looking at ours, we have true and false. Okay, so that's going to give us false. All right, let's go on to the next one, disjunction, or statements. Two statements again, P and Q. This time I used words. The sky is blue. Q is the grass is purple. Okay, this time I used a V symbol, and if you recall, V symbols are or statements. So let's assign our truth values. For P, the sky is blue, that is true. For Q, the grass is purple, nope, that's not true, so we'll assign false. And now we can put them together. So what's the rule for disjunctions? Disjunctions are false only when both statements are false. Both statements have to be false in order to be false. That means everything else, every other scenario is true. So what do we have? We have true and false in our truth table. So that's going to give me true. Okay, let's look at conditionals. These are a little trickier. P statement, 5 minus 3 equals 1. Of course, that's false. Q statement, 5 times 2 equals 10. That is true. All right, we want to know if P, then Q. What would that truth value be? Okay, what's our rule? Conditionals. These statements are false only when the antecedent or the if statement is true and the consequence or the then statement is false. Now, as you can see, the order is important here. We have to pay attention to order on conditionals. It's the only one where order matters. It has to be true first for my if statement and then false for my then statement in order to give me false. Okay, looking at ours, we have false, then true. That's backwards from the rule. So our answer is going to be true. Okay, last one, biconditional. P statement, San Antonio is the capital of Texas, and Q statement, dogs have 2 legs. And we want to know if and only if. Okay, P, if and only if Q. Okay, so let's assign our truth values. For P, P is false. San Antonio is not the capital of Texas. And Q, dogs have 2 legs. No, that is not true either. Okay, what's our rule for biconditionals? Biconditionals are true only when each of our component statements have the same truth value. Okay, they can be both true or both false. It doesn't matter which. And that will give us true for an answer. So looking at ours, we have 2 falses. So that means they are the same truth value, which means my answer is true. Okay, I hope you can see how important it is to know these rules. That's going to be the key here. Know your rules by heart. Okay, let's put this together. So let's say they give us a compound statement here, but they don't give us what P and Q are. We don't know whether they're true or false. So what we're going to have to do is create a truth table that has all of the different scenarios accounted for. Okay, so as you can see, I've started my truth table and I've put in all the headings for us. We need a P, we need a Q, and why do we need that not P there? Well, if you look at our statement, we have a not P as part of our compound sentence, so we're going to need to know what not P represents. And then finally I have our question, not P. Now what is that V? That V, if you recall, represents or. So not P or Q will be our last column. Okay, now remember, we have to account for all the different scenarios. Okay, since we don't know, right away what P and Q are. So we're going to start out by giving all of the possibilities for P and Q. Now I would suggest you do them in the order I have them here every time so you don't forget one. Go ahead and just make this a standard. For P, put true, true, false, false. For Q, put true, false, true, false. And what that does is it makes sure you have all 4 possible scenarios. You can see we have 2 trues, we have true, false, we have false, true, and we also have false, false. The order is not important, but it is important that you have all 4 scenarios. Doing them the same way each time just helps. Okay, now what would our not P column look like? Well, if you recall, not P or negating P simply means to turn the value to the opposite. Well, since I'm only negating P, I only need to look at the first column. So I'm going to look at my first column and I'm going to change each one to the opposite. So true becomes false, false, true, and then true. Total opposite of my first column. Okay, now I'm ready to do my compound statement. Not P, and then my V is or, not P or Q. So I do have to now determine which two columns I need to look at. Okay, I've got not P, so that means I need to look at my third column for not P, and I've got just plain Q, which is my second column. So as you can see by the arrows here, I need to only look at the second and the third columns. That's it. I don't need the first column at all. All right. Remembering the rule, or statements are false only when both statements are false. We have true, false for our first one. Well, that's going to be true. False, false. There's our rule. False, false means false. True, true means true. And false, true means true again. Okay, I hope you can see how that is working. All right, let's do one last example. This time we'll kind of make it a bit harder. This one's going to be kind of a long one, as you can see, and I haven't given you the headings. We're going to start from scratch on this one and determine which headings we need and why. All right, so let's read this first. We have not P. We have an upside down V, which is and. Not Q, that's on the left side in parentheses, and then we have a single arrow, which is your if then, and then we have P, and we have a V shape, which is or Q. All right, to determine what the truth table is going to look like, we need to break this down into all the individual parts. Okay, good way to start, of course, is always with P and Q, so let's start there. P, just run them down, all four different scenarios. True, true, false, false. Good way to start. Q, same thing. True, false, true, false. Look through there, make sure you have all the different scenarios. Again, if you do them the same way every time, you always will. Okay, and now what do we need next? Well, we need to do our simple statements first. We've got not P in our compound statement, so we're going to have that as part of our truth table. So let's start with not P. Go to your first column, turn them to the opposite. False, false, true, true. Notice we also have a not Q, so I need that as part of my truth table. Not Q, go to your Q column, which is your second one, and change them to the opposite. So false, true, false, true. Okay, those are pretty simple to come up with. All right, now let's start putting together our parentheses. Okay, first one on the left-hand side is our not P. Okay, upside down V is and, not Q. All right, which two columns do I need to look at? Not P, not Q. That's our third column and our fourth column only. You don't need the first two columns at all. We don't even want to look at those. Some people like to actually cover them up so they don't confuse the issue. So only look at columns 3 and 4 to determine these truth values. All right, we need a rule. Conjunctions or and statements are true only when both statements are true. Okay, let's look at what we have. We have false, false for our first one. It's going to be false. We have false, true. That's also going to be false. True, false is false. And then here's what our rule states. True, true gives me true. Okay, hope that makes sense. Let's go on to the next parenthesis on the right. This time we have P, and then the V is our or statement, Q. P or Q. This time we need to remember, again, the rule for or, but we also need to look at which two columns we're going to be using. So here's our rule, and then since we only have P, we need to look at the first column, and we only have Q, we need to look at the second column. I don't need columns 3, 4, and 5 at all. Might help again to cover those up so they don't confuse you. So only looking at the first two columns and knowing what the rule says. Disjunctions are false only when both statements are false. Let's run them down. We've got true, true. Well, that gives me true. True, false gives me true. False, true gives me true. And then we have false, false, which is our false. Okay, now we're ready for the big compound statement. Okay, let's figure out which columns we need to look at and what our rule is. All right, columns, we need to look at the parenthesis column. So that's going to be column number 5 and column number 6. Cover up the first 4 so they don't confuse you. All right, if you remember, the rule for the single arrow, the conditional, is they are only false when the first statement is true and the second statement is false. Paying attention to order. First statement true, second statement is false. That will give me false. Everything else will come out true. All right, so our first one we have false, true. That gives me true. False, true again, true. False, true again, true. Now look at the last one. True, then false. That's exactly what that rule is telling us. That gives us false. And here's our truth table. All right, I hope you followed that. The main thing here is to know those rules by heart and to do each column just step by step. Okay, it can get really confusing if you try to do too much at one time. Also, covering up the columns you don't need can help you as well. So to finish up, let's talk about a couple of tips. One, here we go again, know those rules, memorize them. The second tip would be, even if it's a simple problem, I would suggest sketching the truth table. I think visualizing is very, very helpful, especially on the if-thens when the order matters. Okay, and as I said, double check that order. Be sure you're looking at the truth values in the correct order when you're determining your final truth value. Okay, conjunctions, remember those are your ands, can use words other than and. It could also be but, yet, or nevertheless. The rules for those 4 words are the same. For conditionals, which is your if-then, you could also possibly see is sufficient for or is necessary for. And if you see those, they all have the same rule as the conditional. Okay, and by conditionals, the if and only ifs, you could see is necessary and sufficient for. I hope this helps you a little bit. My biggest piece of advice is just to practice. You need to do several of these, jot them down, cover up the columns you don't need, and just take your time on them. You can master them. If you need anything, I hope you'll contact me. My extension is 4285, and good luck on truth tables.